been working at the Guardian newspaper, and one of the most exciting projects that we've been working on has been developing tools for analysing and investigating data leaks and data dumps. So just to give you kind of context for the sort of thing, kind of the background to this work, I'm pretty sure we're all familiar with that friendly smile and that friendly face of Edward Snowden. So that was obviously one of the Guardian's first kind of real data-driven leaks, with around 55,000 documents. And then, as you've sort of seen following the news, the source material for these investigations goes up by an order of magnitude pretty much every time, with Panama Papers being higher, Paradise Papers being in the millions, and presumably, if the trajectory carries on, we could be looking at analysing billions of documents within a single investigation. And what's fantastic is there's a whole ecosystem of tools available for journalists to be analysing this data. Just to quote some of the other organisations who are working on it, there's the ICIJ, who are behind Panama Papers and Paradise Papers. They've just launched kind of open source their new tool DataShare, which is fantastic. We've also done some work with the OCCRP, which is an organisation out of Sarajevo, and their tool Aleph is amazing on sort of more of the entity modeling side that we'll get into later. So to give you a bit of context, we've come out of a golden age of data leaks. And I don't know, unless GDPR spoils all the fun, then I can just see it kind of growing and the need for these tools becoming more and more mature. But I'm going to start by just giving you a feeling for what actually happens kind of at the start of one of these investigations. So the data will arrive somehow. I'll just give a shout out to the Guardian Secure Drop. If you've got anything you'd like to share with the Guardian, Secure Drop is a great way of doing it. But it can arrive on any kind of material. And the process traditionally has been very journalistic focused. You'll see people kind of still having printouts on their desk and combing through the printouts of these tables, of these PDFs, of these contracts. And naturally, when you're looking at even kind of thousands of documents, that approach doesn't scale. If you've got a cache of kind of mixed media, from emails to contracts to videos to pictures, even if you've got 3 people working on this information, it doesn't scale. It's not kind of the same thing. So we've now reached a point where the tooling ecosystem is kind of mature enough to really well support these use cases, and it pretty much functions exactly how you would expect. There's a text box, and you search in the text box, and we're also able to do more advanced techniques like named entity recognition, so identify, say, IBAN numbers or businesses or known aliases of individuals, and really kind of make it faster for the journalists. But again, as we get into sort of the billions territory, it starts to get a little bit hard, and you have a lot of kind of conflicting priorities from various people. Naturally, if you're a journalist, you want to search this data yesterday. But you're a coder, so you need to kind of parallelize the processing, and you're looking at terabytes. So even, with the best will in the world, and with Amazon kind of having your back spinning up lots of machines, it's going to take a while to do the heavy processing, such as optical character recognition, to extract the text from a PDF that doesn't already have machine-readable text. And also there's the fantastic rise of data journalism. So sort of seeing some of the stuff Shirley was talking about in her talk just now. There's the visualization side, and also data journalists, they need structure in the data in order to be able to support their investigations. So we kind of want to go around that route of not just searching, but also bringing structure to kind of unstructured data. And it's much more of a multidisciplinary team that you'll be working with these days. And a variety of roles, like from developers through to traditional journalists, needs a variety of tools. So to introduce you to what we've been building at The Guardian, this is our tool called Giant. It's been under development now for about 2 years. So to give you a kind of idea of how it's deployed, we're running it in both AWS. The Guardian runs most of its digital infrastructure in AWS, and Giant is no different. But we're also able to run the platform entirely air-gapped. So we have an offline cluster with it running there. One of the kind of key decisions that we made when we were building this platform was some of the older investigations had been done using tools that would kind of process data, and they literally had a progress bar. So you'd watch the progress bar kind of go, and it would spin, and it would go doo, 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 and that's fine, but then if it's processing terabytes, the progress bar would spin for a week. And then the journalists are kind of like, okay, well, when can we get hold of this data? And the answer was when the progress bar is finished. So we've architected Giant to be able to search kind of as the processing is completing. So everything is churning away in the background, but you can search what's already been processed. It's a much more kind of immediate feedback and immediate system for people to use. And we've kind of built it, we conceived of it as an app for search. I mean, you can kind of see it's got similarities to maybe Kibana from Elastic that you've used. It's got kind of a histogram and a big, nice free text search field for searching for whichever kind of dodgy billionaire you want to search for. But we've realized kind of over time that what started off as an app has become much more of a platform. And whilst we were targeting kind of big bang investigations, your Panama Papers, Paradise Papers kind of use cases, the capabilities that we've built are useful for the whole newsroom. And the ability to OCR text, to search across all of the source material that you've gathered is useful for every journalist. So as well as kind of giving you a feeling for what we've been building, I also want to kind of tell you a tale of how sometimes what you think is an app eventually becomes a platform, and also vice versa. So to go in a little bit, I'm not going to go kind of too technical. So what kind of is the system we've built? I've decided to represent it in this presentation as a poor, like low quality image of a dry cleaning machine. I don't know why that's kind of stuck, but you put in a bunch of data, you've got source material, like I said, documents, videos, all kind of unstructured data, and you roll it through the dry cleaning machine, and stuff comes out the other end. It's really interesting, kind of the plurality of material that we've had to work with, and finding some data sets to test has been really interesting. One of the great data sets we can test with is the CIA released all of the files that they scraped off Osama bin Laden's computer when they stormed his compound in Abbottabad. And weirdly, it was a great test for our video support because he has full-length anime episodes on his computer. So it's quite weird when you're sort of searching through these testing videos and then you start playing some anime. It's pretty surprising. And as I said, you can search and filter by time. It's very similar to Kibana. It has a very inviting free text search box that makes you kind of want to click on it. And the advantage with this tool is when you have multiple data sets. So we're starting to not just use it for a single investigation, but upload multiple data sets. And you can start to form links. Maybe an individual or a company that's mentioned in one data set is mentioned in another. You can start to thread emails, as we'll see later on. And it's providing, getting the machine to do a lot of the heavy lifting that journalists would do before. That kind of trawling process. A lot of tools at the moment don't capture the process that the journalists go through when they're working with the source material. So whilst we can provide the computational heavy lifting of the OCR and the named entity recognition, we're also working on features for collaboration. So imagine that you're collaborating with an office in a completely different time zone. When they did Paradise Papers, there was representatives from tens of different countries, all of which had their own interests, but maybe shared with others. And imagine you've got like a notification system, so someone is searching and they found something about an individual that you can then see when you come in the next morning that there's more stuff for you to investigate. So we're really kind of pushing, not just for the kind of more traditional processing side, but also to model and to empower and make faster a lot of what journalists tend to do when they work with this material. But actually, in the background, how are we implementing this? So I'm just going to quote technologies at you. If you don't already know them, this is a useful cheat sheet. So at the core of so many of these platforms is Apache Ticker, which is a Java library, and it's amazing at kind of doing lots of things, but we use it to do two things. It answers the question, what the hell is this random file that I've got? And it's pretty good at answering that question. It can identify most things. And it can also extract the text from files and extract the text from Word documents. We've got OCR as well. Coming back to those red lines I was talking about, we need it to be able to run offline as well as online in the cloud. So we can't use, say, Amazon's optical character recognition techniques or Google's cloud service. So we're just using Tesseract 4. Tesseract 4, I think, is probably released now, but it was a Google project where it was doing traditional style processing, and they rewrote it to use neural networks, and it's pretty much as good as what you would get if you would use one of those cloud systems. And then one of the key features is being able to see these documents in situ. So you don't want to necessarily have to download a Word document from some secret material just to have a look at it, but it might have some images in it that you're not seeing in the text. So we use an incredibly advanced technique to render these previews so that people can see them in the actual app itself, and it's called shelling out to LibreOffice. And this is incredible. I mean, we've heard so many good talks over the years at Jay on the Beach about distributed systems and recovering from failure. And it turns out recovering from failure is really easy if you shelled out to the process, and then it can just crash and it doesn't matter, it doesn't take anything out. So sometimes the simple solutions work really well. And then this is also enriched by custom code that we've written ourselves. And this is so valuable for the journalists that we can kind of have a tight feedback loop with them when new source material comes in. We're able to write what we call extractors for it. So a great example of that is Outlook for Mac backups. So Outlook for Mac backups is a whole bunch of XML in a zip file. And some previous tools kind of didn't necessarily identify that as email, so you couldn't have as rich a UI. But because we're working directly with the journalist, we can then go ahead, build an extractor, and then we got it done in a couple of days. It was pretty good. And at the core of the system are the two databases. We've got what we call the manifest, which is where we store records of all the data that we have and what's linked to what. So maybe it's the folder structure in the original material or emails sent from one person to another. It's slow-moving, it's transactional, it's the system of record of the material we have. And then we also have the index, which we use for search. So the manifest, we're using Neo4j, which is a graph database. There's been amazing work done in the journalism space with Neo4j. I'd encourage you to go and look at the ICIJ website, where they have some data kind of in a pre-made Neo4j that you can download that they got from Panama Papers, and you can see the connections between the individuals that they were modeling. It's a really, really pretty graph. I don't have a screenshot, unfortunately, but trying to translate between those pretty graphs and something that's journalistically useful is quite challenging, because if you give a massive graph to a journalist or the Cypher query language, then it could be challenging. So we've kind of tried to take a middle ground, so we're using Neo4j to power email threads, which is that screenshot you can see on the right. And whilst we have that power of the graph behind us and we can do that mining work, at the end of the day, it really supports them for that initial kind of search phase of the investigation, because ultimately, what do they want to know? They want to know what happened at the end of the dodgy conversation. So you just click the end, and then the great thing about email is email has all of the replies in line, so you then have just a pre-made kind of list of everything that went on, and it's really good. We're kind of just using Neo4j in pretty much a relational way, and so again, coming back to that app and platform kind of idea, we knew that we were going to need to represent graph-based data like these threads. But we kind of ended up shoving everything into Neo4j, and actually we've come to use it more as a transactional database, like a traditional relational database. And that can lead to some interesting challenges. So kind of a good story for you is we were churning through some data on our offline cluster, and it started off really quickly, and then we were running it overnight. And we came in the next morning, and all of a sudden it was doing maybe like 1 document a second or half a document a second. It had gone from really fast to really slow. And Neo4j has amazing query profiling. You just stick the word explain on the front of the query, and then it tells you kind of, not only in like the traditional SQL style of what am I planning to do to answer your query, but it will also give you estimates of data volume. And it turns out we just missed a label on a query, it was missing an index, and then that was the challenge. So Neo4j is fantastic, but kind of fiddly for those sort of things. And when it comes to search, we're fairly straightforward. So as a show of hands, who in their system just puts data into Elasticsearch and then just runs queries? No customization, no anything, just throw it in. There's some hands, I knew it. Yep, it's fantastic, it works, it's the standard for search. Kind of the lessons we've learned from this have been around the use of nested fields, which is really good. So everything is deduplicated. So if a document appears in multiple data sets, we only have one representation of it, we put it in Elasticsearch. And then we have nested fields for the metadata search. But more importantly, we have nested fields for language support. And this was fantastic because as we were going along, our OCR process would support, I think it was English, French, and maybe Spanish. And then we had reason to add Portuguese. So we were able to add Portuguese search with proper Elasticsearch language analyzers and stemming support and all of that by just adding an extra nested field. We didn't have to reprocess the data. We could enrich kind of that search capability for journalists as they were working on the data, which was really exciting. And then the workhorse of all of this is actually just processing the data. Oh, wow. So this is The Guardian's official slide template, and it's officially not working on this screen. But I'll describe it to you anyway. So we've got the notion of extractor, and we started working, coding this on the JVM. So ultimately, an extractor is just implementing a Scala trait. It's just a function that takes some bytes and then returns a result. Maybe it returns some text, maybe it returns some new things. And we started to kind of come up with this idea of phases of the processing, because the extractors themselves are quite straightforward. They're just kind of bytes in, data out. But we have various phases of the investigation that we needed to model. So one of the first things you want to do is you don't necessarily want to process everything as you're, say, pulling it off a USB drive, because you might only have that USB drive for an hour. The person who has bought the source material, not only might they actually need to leave to go and do something else, but we might need to remove the source material for legal reasons. So you only want to copy it as fast as you possibly can, and then have another phase where you identify what actually is that material, and then prioritize the extractors that you're actually going to run. Maybe you want to pull out tables from Excel documents. And we found that we were writing quite a lot of kind of scheduling code, and our app that was originally just kind of files in and then we were searching it had a lot of kind of ad hoc running of tasks in the background. And we needed to take a step back and start thinking about what actually is kind of the core of this process, and maybe like focus less on just a single app and more about this kind of platform that we were trying to build. So as I said, what are we actually working with? What are we working with in a fundamental computer science kind of manner? Well, our input is, it's a file, it's got some bytes, and then we know what the type is because Ticker told us, and we know what the size is. And the tasks that we want to perform, maybe we want to OCR some PDFs, maybe we want to generate email previews, rendering the HTML from the actual email, or maybe we want to extract tables from Excel documents. You can imagine there's a massive plurality of these tasks that we want to run. And we knew that our data model was reasonably sound. And this is another great kind of lesson that I've learned, which is we were trying to add visibility restrictions. So if there were multiple data sets uploaded into the tool, you might not want everyone to be able to search everything. So we kind of structured things in a certain way. This has got the buzzwords for various parts on it, but you can imagine like a collection is a data set, and then an individual ingestion is when you actually pulled it off the USB stick, and then we've got some folders underneath it, and then underneath we've got that deduplicated blob, so that if the same file appears in multiple places, we only store it once. And we knew we kind of wanted to restrict the visibility in the search, which meant we had to get the information about what data set we were processing into our index alongside all the other stuff. And then we had to, if we saw it again, we had to process it again and add new data into the index. And this kind of led us to a fundamental realization that we'd built a trait for our extractors. So our extractors just followed a single pattern. But actually, fundamentally, there were kind of two types of extractors. There was an extractor that kind of created new things. So it was a zip file, or maybe it was a PST email archive. It's got things inside it. It's got structure inside it. And there's other extractors which just enrich existing data. So maybe it's the OCR process that just adds text to an existing document. So the solution was highly technical and just involved running the processing again. So when you saw the document in a different data set, you run the processing again, but because it's deduplicated, you can cache the processing results by not only the hash of the file, but also the version of the extractor that you're running. And this is brilliant because whilst conceptually you're running the processing again, of course it's just cached, so you don't have to perform all the expensive OCR again. And the key point is that my colleagues Sam and Simon, when they started the project, they spent a lot of time thinking about this data model up front and used a lot of their experience to say, how are we going to structure a model to try and represent all possible files we could ever see in unstructured data? And then the real validation of that data model was when it led us to a good solution for a problem that we thought was challenging. So what were we working with when it came to the extractors? We started to think less of an individual app and more as a platform, more of a generalized notion of kind of the task that we had to do. So not only do we have the input, which is the blob and the MIME type, we've also got a function that we're trying to apply to it, the tasks. And then you can start to look to schedule these much more generally. It becomes much more of a problem that we can apply existing task scheduling solutions to, like Kubernetes, that we'll get onto later, and just start to, it's advantageous for us when we're running offline as well, because we can start to tessellate and really take advantage of the hardware much more than just blindly running processing again. Our app had sort of started to evolve into a platform. And technically, this evolution was happening, but this evolution was also happening with how our users were perceiving it as well. Because, as I said, we're not necessarily trying to just target big bang investigations. Otherwise, as developers, we'd be sitting around waiting for the next big thing and then hoping that it would work. So we've been making it accessible and making our tools useful to everybody in the newsroom so that they can upload even small amounts of files. Because ultimately, if you're a journalist, like, easy access to speech to text processing is fantastic because you have to spend less time writing notes. Or OCR processing is also great, and it encourages people to start putting their data into these systems, and then the systems give them the capability to then start being a little bit more kind of not necessarily analytical, but a little bit more investigative because they have the power to search and it's kind of there at their fingertips. And so rather than have a lot of material that would have been really time consuming to search and they didn't have a chance, we're using the platform to build tools that let them kind of search and find what they need to see. So here's where things are looking currently. So these tasks, like I said, generalize really well into containers. Ultimately, like an extractor as a container can just wrap up its dependencies. So if it needs, something to extract Excel documents, then the actual kind of our code base doesn't need to worry about that. It becomes much more pluggable. And as I said, you can cache by hash inversion. And this is really good because you don't have to reprocess the data as you're moving along. So we can build new UIs. We can work on better email threading, better kind of slicing up of structured data without having to reprocess our data. And we also have a very, very strong knowledge of exactly what data as sensitive data as an organization we've got hold of. And this move to containers helps us to kind of bridge the gap between our two deployment models. So as I said, we run in AWS. Fargate is quite interesting for us as a concept, or the idea that we could run lots of containers and spin them up without necessarily thinking about the underlying VMs, because our work is really bursty. And that background in there is, it turns out Fargate is also the name of a shopping center in Sheffield. So there's part of me that just loves the idea that actually when you're running your containers, it's all just running in the back of a Marks & Spencer's in Sheffield somewhere. And the other screenshot is our original offline cluster. So that's Investigation 01 through Investigation 08, which were repurposed desktop computers that we went around taking off people who didn't use them anymore. And it's incredible the amount of journalism you can do with 8 kind of reasonably powerful desktop computers. That's powered some investigations that have actually hit the front page. But something like Kubernetes can let us code against an API that means we don't have to worry too much about managing each deployment model. And this notion of moving towards a platform is not just important technically, but also because it matches kind of, like I was saying, how journalists want to be able to use these capabilities. We should, as developers, have the ability to move fast and build new tools for processing new types of data or for new use cases that come up. And this also is key to kind of collaboration. So as I said, the ICIJ have data share. They've got some fantastic data extractors, and ultimately, the act of reading a Word document is pretty commodity. We probably don't want to spend time trying to re-implement tickers parsing for Word. And Aleph from the OCCRP has an incredibly rich knowledge of entities and how they are related. So how can we, define APIs so that we can then have access to that data as we're processing things coming in? So kind of with Giant, we're targeting that initial phase of when you've just got access to source material and you want to see what's inside and you want to really kind of dig deep. But how can you take advantage of a big, wide entity graph that means you don't have to go hopping from one shell company name to another shell company name manually? And I'm kind of based out of the editorial tools team in The Guardian, so we're also responsible for the content management systems, image management systems, pretty much everything related to production. And we're really clear that this collaboration is the future, not just for investigative tools, but also potentially the future for content production tools. So we've having some really interesting conversations with other publishers about how we can kind of share the work we've been doing building text editors for journalists to use, and how maybe we could, avoid reinventing the common parts and focus on what's important to our organization, not just now, but also kind of strategically in the future. Where do we want to be focusing our investigations as we move forward? And a great example of this collaboration is actually one that we've done internally. So my colleagues Sam and Laura were working with Kaylin and Pamela, who are two data journalists. And they built a tool called Laundrette. So the sell for Laundrette is quite simple. Lots of good journalism comes from sending lots of freedom of information requests. So you can send them all off, and then they come back. And it's at least guaranteed that each jurisdiction for the government in your country is going to send them back in a slightly different format. It's also not unheard of that they might send them back in a deliberately opaque format, maybe just printed it out, photocopied the whole lot so there was no kind of like machine extractable information, and then just send them to you. So you've got 10,000 PDFs essentially, and what you really want is a spreadsheet so you can start doing data journalism. Now, kind of traditionally, you'd go through this with a command line. Maybe you'd be using IPython or something, and you'd start typing some regexes, and maybe it would match, and then you'd have to go and find the document. And what we were able to do with Laundrette was repurpose that platform that we started to build with Giant and build a tool that makes this whole process a lot kind of quicker and shows you the information that as a journalist you need to see. So what you need to see are, once you've written your regex to extract the information, you need to see the documents that don't match. So it immediately shows you, out of this sample that we're testing on, what's not matching. You can click through, see why it's not matching, start to pull out other names. This has reduced the time it takes for data journalists to do this processing by literally days. And it allows them to focus on finding the stories within the data rather than just cleaning the data itself. And it's a fantastic example of how this collaboration between the more traditional coding side, when you combine it with a platform of capabilities, can quickly produce tools that are having real impact. So this evolution from kind of building this little app with a text box through to a platform, I think is really interesting, and I think it's kind of an interesting lesson for me and one that hopefully I can impart to you. A great example is the image management system that we work with, a system called the Grid. It was designed from scratch to be a whole bunch of microservices. I think it's like 10 microservices. But users were actually seeing it ultimately as just a way to search and find a picture. The majority of users are just finding a decent picture to embed in some content and move on. It was structured as microservices, but perceived as an app. So then it's quite challenging for us as developers to react to how to maintain this or to fix it or to update it, because you have to then work out which part of the microservices is doing which part, and all of those kind of challenges that come along with it. But it wasn't matching the user's expectations. And Giant was the reverse. With Giant, we started off building an app, but then the user's expectations drove us to building a platform. It was obvious that this capability that we were building would be useful if it was available in much more of like an API style. And I feel like moving from one to the other is something that you balance up just like you would address tech debt, just like you would do refactoring, just like you would write tests. Understanding how your users perceive your software is sometimes a good indicator for how it should actually be structured itself. And we've got fantastic tools for making this much better, for doing this process better now. I mean, like from the back-end side, obviously you've got protobufs and thrifts, so you can define your APIs and reuse them without having to re-implement them. But also it's really exciting to see kind of the talk rising about design systems on the front end, because then when you combine that with something like React and TypeScript, you've got the ability to reuse these front-end components and to customize them, but in a way that is really mature and is as safe as your compiler telling you that you've messed up because you've renamed a field on the back end. So I'd encourage you all to think about that kind of trade-off. But the number one lesson for me from The Guardian is that actually the way your users perceive the software that you're writing is sometimes quite a good indicator for how it should be structured in the back end. So that's it. It's a quick roundup of Giant and how we've been building it. These are pictures of some of my colleagues who've worked on it, just to give them a shout out. And I'm happy to take any questions. How are we looking for questions?
Yes, we have received some questions. So
right.
let me see if some others are coming. So, first one someone is asking, are you ever worried about exploits in things you import? Or, apart than air gapping in extreme cases, do you have other things in place?
Yeah.
Hard separation between extraction and analysis, storage?
Yeah, I think that's a really interesting question. I mean, kind of not to go too much into what we do specifically. Ultimately, as with any kind of InfoSec problem, it's all about the adversary that you're worried about. So you need to be doing proper threat modeling and know kind of who you're up against. And certainly, you know, we kind of built almost like a menu that we could give to people. So given a certain data set, here is the options that you have from hosting it in AWS through to kind of the full air-gap solution. So then you can make it kind of a choice for people, because ultimately as developers, we can't necessarily make that choice about a threat, but we can at least provide technical information so that people can make informed choices. And with regards to actual exploits in the software itself, I think we could be worried about it, but again, it's the adversary that you're up against. And certainly, like, there will probably be situations where an investigation would be so sensitive that the use of these tools we would have to think about quite hard. But I think not just kind of within the Guardian, but also outside of the Guardian, and people using these wider tools, like ICIJ's data share is open source, for example. Giving people and empowering people to give them the ability to use these tools is incredibly important. And if we sort of spent a lot of time working on really kind of trying to protect it as much as possible, then we would be losing the focus on the search side and the analysis side. And there's already fantastic tooling for kind of cleaning things. And I forget the name of it now, but there's one where you can plug a USB stick into a Raspberry Pi and it tries its best to get rid of kind of bad stuff. But yeah, we're kind of not necessarily trying to solve InfoSec problems. We're trying to solve kind of search accessibility and collaboration problems.
That's cool. We have got some other questions. So there's another one that mentioned. You mentioned terabytes for OCR, and the tool and this tool allows journalists to add annotations to fix missing characters or in the process of OCR. Does this manual cleanup flow back into terabytes for training?
You know, it really should. I sort of joked about using Elasticsearch completely out the box. We're using Tesseract completely out the box as well. And that reminds me of actually a really good story. So who's been to those sort of like meetings where you get together with lots of people from the organization and everyone talks about what they're working on? And sometimes it can be people who are talking about one project, talking to people who are talking about another project, and everyone is not kind of really connecting. Well, we went to one and we just added Arabic support. And none of us speak Arabic, so we pretty much just enabled it as a language analyzer and then as a Tesseract command line argument. And we saw that some Arabic text was coming out, and we thought, yeah, that's Arabic. But we thought, you know, someone should actually validate this. And it turns out one of the people in the charitable arm of The Guardian was fluent in Arabic. And so she kind of came and gave us some really detailed notes, not just on like accuracy, because we weren't necessarily kind of trying to focus on going back to Tesseract to train it to be much better at Arabic. But is this going to be useful if some data came in tomorrow and we wanted to do an investigation in Arabic tomorrow? And we were able to sort of establish that it was just about good enough. And then we're able to, kind of as developers, make that technical choice of if our support for language XYZ is not good enough, then we can go back and focus on the training. And Tesseract has fantastic kind of documentation and readmes about how you could train it to better suit your use case. I guess the challenge for us with training is data volume. We might not necessarily have enough annotated data to kind of do accurate training, but the possibility is definitely there.
All right. And we have one last question. That when MI5 came to Guardian for Snowden's documents, they destroyed hard drives with hammers, right?
They did, yeah.
So what do you think that will do? What they do, what will happen when they come to seize or destroy data in this system? Will they be able to get a copy of these docs?
I mean, so ultimately, I'm not kind of going to go too much into that. That's much more of like a management decision about what to do with the data and whether to destroy it. What we have done in our architecture is we've aimed so that you can retain metadata. So you can retain not just kind of OCR results, which would probably still count as the original material. But you could also potentially retain journalistic annotations. So if people had categorized it in a certain way, or if people had started doing an investigation, depending on what the legal advice would be, we might be able to retain that metadata or spin up a new instance of it and apply it somewhere else. So we have sort of tried to architect for that possibility. But ultimately, it really is kind of a much higher decision than my pay grade when it comes to that sort of stuff.
All right. So that was all the questions. So Michael, thanks for your talk. We're done. So please welcome him with a big applause.
Thank you very much.